So in the last class, we were discussing about the economic operation and how the optimum schedule is obtained. Optimum schedule can be obtained and what is the relation. So in the previous lecture, we have obtained a relation. For each plant, the incremental fuel cost should be equal, and it should be equal to Lagrangian multiplier. df1 by dp1 plus equal to df2 by dp2 equal to etc. dfn by dpn should be equal to lambda. Lambda is Lagrangian multiplier. So that case is actually, if we are not considering the transmission line loss, but in the case 2 we have to consider the transmission line loss. So the economic dispatch including the transmission line loss. So here what will be the difference? Here also we have to minimize total fuel cost I equal to 1 to n fi subjected to what? Pd plus PL equal to sigma I equal to 1 to n pi. So the condition will become what? Pd plus PL minus sigma I equal to 1 to n pi equal to 0, where PL is the total system loss, which is assumed to be a function of generation, and the other term have their usual significance. The all other terms we have defined earlier. Here for the only term which is coming as a new term is PL. PL is not defined earlier. PL is actually a transmission line loss. That means if here we are having a general first bus is here and this is our second bus 1 and 2, then this line is having a loss. That loss always depending on the generation. That is the point you have to note down here, because this loss is always a function of generation, but demand is not a function of generation. Demand is a constant, but loss is not a constant. Loss is always according to the generation, how much power is generated by this plant. Depending on that, this loss will be created. So loss is always a function of generation. Now what we have to find, again the same thing we are following here also, by making use of the Lagrangian multiplier. The auxiliary function is obtained as f equal to ft plus the condition. What will be which quantity to be minimized plus the condition. ft plus lambda into condition is what? Constraint is what? Pd plus PL minus sigma equal to 1 to n pi, where lambda is Lagrangian multiplier or the incremental. Another name is incremental cost of the received power in rupees per megawatt hour. Its unit is again rupees per megawatt hour. Lambda unit is rupees per megawatt hour. Now differentiating f with respect to the generation pi and equating to 0 give the condition for the optimal operation of the system. So here dou f by dou pi, dou ft by dou pi, the same. First thing is dou ft by dou pi plus lambda into the second term will be what? PD. Differentiating PD will give you 0. So this will this term differentiating with respect to pi will give you 0. Now PL is not a constant. It is depending on pi. So what we can say, second term is dou PL by dou pi minus 1. How we are getting the 1? That we explained in the earlier lecture. Now dou ft by dou pi plus lambda into this term can be taken just write again dou ft by dou pi plus lambda into dou PL by dou pi minus 1 equal to 0. The same thing only, same equation here. Now this term is taken to the right side. Dou ft by dou pi equal to lambda into just reverse, because when we are taking to right side means it will become negative. Lambda into 1 minus dou PL by dou pi. Now ft equal to what? F1 plus F2 plus F3 plus etc. plus Fi plus Fn. It can be written as dfi by dpi. So you can say dfi by dpi equal to what? Lambda into 1 minus dou PL by dou pi. There is a difference. Earlier it was what? Equal to lambda, but there is an extra term coming here which is 1 minus dou PL by dou pi. Now it is taken to the left side again. So it will be dfi by dpi into 1 by. So it will become what? 1 by 1 minus. 1 by 1 minus dou PL by dou pi into equal to lambda. The term 1 by 1 minus dou PL by dou pi is known as penalty factor of the ith unit. Penalty factor Li. So we can write dfi by dpi into Li equal to lambda. What we got earlier, this term Li was not there. It is just like df by dp equal to lambda. If we are not considering the losses, it will be like this. But here an extra term is coming L into Li. equal to lambda. Therefore, the condition for the optimal operation is what? df1 by dp1 into L1 equal to df2 by dp2 into L2 etc. equal to what? Lambda. So earlier it was like incremental cost of each plant should be equal to what? Lambda. But if you are considering the line losses, then it will be what? Product of the incremental cost and the penalty factor of each plant should be equal, and it should be equal to what? Lagrangian multiplier. Now incremental transmission loss, the term dou PL by dou PI is known as incremental transmission loss at plant I. So consider the transmission loss in terms of the generation. So here we can see the equation PL equal to sigma m sigma n PM BMN into PN, where PM is the PM and PN are the source loadings. That means generation at each bus, the generation at each bus, and BMN is the transmission loss coefficient. For example, I am taking two buses 1 and 2. There we are connecting two generators. First generator is having a power generation of P1, and second generator is having a power generation of P2. In between these two buses we are connecting a transmission line. Now we have to find the power loss PL of this line. So this transmission loss of this line always depending on what? The generation at bus 1 and bus 2, or generation of each plant P1 and P2. How we are finding this PL? That relation is obtained, this PL relation is obtained by using this equation. PL equal to sigma m sigma n PM BMN into PN. So consider the first bus P1. So PL is equal to what? PL is equal to first coefficient will be, there are three, in this case 1 and 2 means the three coefficients will come. One is B11, second one is B12, third one is B22. That means self coefficient is there, B11 and B22, and mutual coefficient is there, B12. So if B11 means what will be the power term? P1 square. So B11 into P1 square plus next term is B12. That means the power will be what? P1 into B12 into P2. Now the third term is what? B22. So with the B22 which term will come? B22 into P2 square. So this is the equation if there are two generators are. If there are three generators, what will be the relation? For a 3-bus system, 1, 2 and 3, the equation will be what? B11 into Pg1 square plus B22 into Pg2 square plus B33 into Pg3 square plus 2 into B12 into Pg1 Pg2, or we can say Pg1 into Pg2 into B12 like that, and B12 into B2 B12 into Pg1 into Pg2. So actually the 2 is not here. Pg1 into Pg2 into B12. Yeah, 2 is there. Actually, they are summing up two terms. That is why 2 is coming here. So it will be 2 into B12 into P1 into Pg2 means Pg1 into Pg2 into B12 plus Pg2 into Pg1 into B21. Both are similar. That means there are two terms will come in this. One is P1 into P2 into B12 plus P2 into P1 into B21. So we are adding both these B21. We are adding both these B12 and B21 are equal because they are representing the same line only. And then we will get what? 2 into B12 into Pg1 into Pg2. Similarly, 2 into B23 into Pg2 into Pg3 plus 2 into B31 into Pg3 into Pg1. So this is the equation for if there are 3 buses are connected. If any bus is not connected, not interconnected means, that means if this line is not connected here, then what will happen? This B23, this term will not be there. This term will become 0. Okay. So this is the expression for the transmission line loss in terms of the generator. So with this we are completing that part. in this part we have discussed how we can optimally schedule the generation capacity, generation of each plant. In two cases we considered, in the first case without the losses and in the second case with the losses, and we explained out about how the power losses are expressed in terms of the generation capacity. So we are stopping here. Thank you.